All right, 7.3. We're now adding and subtracting the rational expressions. And this one we're doing with monomial denominators. So just like with adding and subtracting fractions and regular numbers, they tend to be a little bit more difficult than multiplying and dividing fractions because of the one thing you got to do. You need a common denominator. So we're looking at starting off with monomials in the denominator, just one term in the denominator. In 7.4, we're going to look at, well, what happens if those are binomials and trinomials and how to deal with those. Let's start just with our remembering how to do adding and subtracting. Common denominator is needed, so we look for our lowest common denominator. Okay, we got 3 and we got a 4, so the LCD is 12. I need the first one to be over 12 and the second one to be over 12. What did we do to 3 to get to the 12? Multiplied by 4. So I got to do the same thing to the numerator because I can multiply by 1 to keep it as an equivalent fraction. What did I do to the second fraction? Multiplied it by 3. Got to do the exact same thing to the numerator to make it work as well. So then we get 8 plus 9. Add them together and we get 17/12. In the first one, to get the LCD, we were able just to multiply the denominators. That doesn't have to be the case when we look at the second one. Our LCD is not just 5 times 20. It is 20. So in this one, we've got to get them both over 20. This one already is, so it stays. And this one I needed to multiply by 4 over 4 to give me 12. And then we just add 12 plus 9, sorry, 12 minus 9, which gives me 3 20s. Always look at the end. Can I take it down to any lower terms? No, I can't. Next one. When I look at these, again, it's not just 6 times 9 to give me the LCD, and it's not 6, and it's not 9. So we actually have to look a little bit further about where the LCD is. And on this one, the LCD is equal to 18. And I'm going to go right back to the whole process of finding an LCD, the lowest common denominator, which is the same as the LCM, the lowest common multiple that you were shown in 10C. The reason I'm going to show you this is because it's going to be necessary to be able to use when we get variables for the denominators and find the lowest common denominator of those. 6 and 9. We need the lowest common multiple, which is the lowest common denominator of them. Break it down into its prime factors. 6 is made up of 2 times 3. And 9 is made up of 3 times 3. We need to find out what is going to actually be common between them. So this is what I would recommend for you. And I'll show you. It's a little bit confusing when you first start, but keep at them and it'll make a lot more sense. When we break up our 6 into its prime factors, we've got 2. So that's got its own column for the 2's. Then we've got a 3. That's got its own column for the 3's. Now we go to the 9. The 9 has a 3. Oh, I already have one column for a 3, so I can put 1 in there. I'm only able to put one number into each column here. And then the next one, I need another 3, so I've got another column for 3s. Most of you can do this in your head without having to worry about that for numbers. It's going to become important when we're looking at variables and factors. To get the LCD, we're just going to bring down each column. So this is a 2 column times a 3 column times a 3 column. 2 times 3 times 3 gives us our LCD of 18. So 18 and 18. And then you'll say, okay, well, what did I have to multiply the first fraction by to get to 18? And we know that it was 3 over 3. That can be found actually from this table by looking at the 6 from the first. Which one of these is blank? We're missing the 3 column. Same thing is going to happen with the 9. What did we need to multiply the 9 by? 2 over 2. And we can find that by looking at the 9 row. And which column is blank in the 9 row? Oh yeah, the 2's are. So then we get 3 over 18, and we get 4 over 18, 14 over 18. And then we subtract them and get negative 11 over 18. Let's apply this now to variables. It's exactly the same process. I do actually recommend that you pause it now, try them yourself. See if you can apply this, and then start again. You will learn a lot more if you see where you're going to make your errors to start with. All right. So let's go through that first one. Luckily, this first one has common denominators. So we can just add them straight up. So we've got 1 over 2a plus 2 over 2a is going to give us 1 plus 2, 3 over 2a. But we always have to remember, if you've got a variable in the denominator, you've got a restriction, comma, a cannot equal 0. Let's go to the next adding one. We've got 5 over m plus 4 over m squared. I need to have a common denominator. Well, I've got m and I've got m squared. Well, if I multiply the first one by m over m, I can get it into m squared. So I'm going to adjust it that way. My LCD in this one is equal to m squared. So we get 5m over m squared plus 4 over m squared is going to give us 5m plus 4 over m squared, comma, m cannot be equal to 0 for either of them. They're both the same restriction. Put that up over here. And let's look at the third one. Now we're going to do some subtracting. We've got 2 over 3x minus 1 over 6x. So 2 over 3x minus 1 over 6x. They both have an x. That's good. So I just need to multiply the first term by 3 to be able to get to a common denominator. Oh, sorry, by 2. Which gives us 4 over 6x, good, minus 1 over 6x. And now we can just subtract 4 minus 1 gives us 3 over 6x. But we need to always look, can I reduce at the end? And this one, yes, we can reduce, because we can reduce the 3 and the 6 together. Which gives us 1 over 2x. Comma, we need to do our NPVs. x cannot be equal to 0. You may start seeing a pattern that all of them are cannot equal 0, cannot equal 0. That's going to be the case because we're dealing with monomials today. In 7.4, it will be different because we'll have binomials. And then the last one, 1 over 2m minus 4 over n. Ooh, this one we got a little bit more to do with it. In order to get them the same, I actually need to multiply this one by n. N over n. And this one needs to be multiplied by 2 over m. They don't have anything in common, so it'll be 1 times the other. Which gives us n over 2mn minus 8m over 2mn. And we can now just bring it together. N minus 8m over 2mn. And we can't cancel anything off because we've got a binomial. And we love binomials, so you have to cancel off binomials, sometimes monomials, but we can't just cancel off a term. Comma, m cannot be 0, and n cannot be 0. And like I just said, the strategies for adding and subtracting rational numbers is exactly the same as adding and subtracting rational expressions. We need to get a common denominator and then add or subtract the numerators. And the last thing we have to do, though, is our NPVs, an extra step on there. For example, let's look at this here. And this is where I was talking about breaking it up into its factors. I did the prime factoring for 6 and 9. We'll do the same kind of thing here with these. So if we look at 6xy, its prime factors are 2 times 3 times x times y. 15 is made up of 3 times 5 times x times x. Let's put that into a chart. So 6xy and the 15x squared. I've got a spot I need for a 2. Then I need another one for the 3. Then I need another column for an x. I need another column for a y. There's my prime factoring of 6xy. Let's go to the 15x squared. I've got a 3. Hey, I've already got a column for 3. I put a 3 there. 5. I don't have a 5 column, so I'm going to have to make another one. X. Oh, I got a column for an x. But I can only put one x in that column. I can't put more than one. And then I've got another x, so it's got to go over there. My LCD is going to be made up of, bring each of these columns down. I need a 2, I need a 3, I need an x, I need a y, I need a 5, I need an x. Let's combine that into one monomial. Which gives us, oops, as you can see here, so you can see we've got the 2 times the 3 times the 5 times the x times the x times the y, which gives us 30 x squared y. And that's my LCD. Multiply those up together. So now you don't have to use that box method to be able to find the LCD. It mostly helps when we have binomials to deal with. You can do it without, for sure. It's just one of many strategies to be able to do it. If it helps you, use it. If not, then make sure you have a strategy that does work for you. So we got to look here. We got to say, I'm adding, so I need a common denominator. I cannot cancel off because there's adding in the middle. You can only cancel off between fractions if you're multiplying, because then you have one divided by the other. This one we don't. So we have to go to a common denominator to be able to go further. So we've got a 7 and we've got a 3x. Common denominator between those ones is going to be LCD 21x. They have nothing in common, so we just multiply them. Well, the 7, in order to go from 7 to 21, we need to multiply by 3, and we need to multiply by the x. So we're going to multiply this one by 3x over 3x. So this is going to give us 6x squared over 21x plus the second one. We have 3x, we need to get 21x, we're going to multiply by 7 over 7. And that gives us 35 over 21x. And now, because we've got a common denominator, we can just add the numerators together. 6x squared plus 35 over 21x. The last thing that we should be doing with this answer is checking to see, can I factor anything out of the numerator that would be able to divide and reduce with the denominator. We don't have anything in this question, so we're just going to put on our NPVs. Do not forget about NPVs every time. This whole chapter long, every question, NPVs. What's going to make the denominator 0? Well, if I put in an x of 0. So x cannot equal 0. And there's your answer. Next one. Looking at these ones, I've got 5ab, 4b squared. You want to use your little box method. Go ahead. If you have your own method, work with that as well. So the 5, the A, the B, they each get their own column. The 4 is made up of 2 times 2. Because there's no 2's even in the first one, I'm going to leave it as a 4. I could break it up into its primes, but then it'd be a 2 and a 2, and it's going to multiply anyways. Back to a 4. But then I've got a B. So I've got a 1B is a B times a B. So 1B can go into the first B column, and the second one needs its own B column. Now I've got my LCD here of 5 times A times B times 4 times B, which is 5 times 4, 20, A, B squared. There's my LCD. So coming back into here, I need 20AB squared minus 20AB squared for the denominators. Now let's work the numerators. What was the first fraction missing? It was missing that one and that one. So that's what I'm going to multiply it by, a 4B. What was the second one missing? Well, it was missing a 5 and an A. So that's what I'm going to multiply on this one by. 5A over 5A. And that now gives me 4B times 4. I get 16B minus 3 times 5A, 15A. Now we combine the two fractions. 16B minus 15A over 20AB squared. Can I factor anything out of the numerator that would be able to reduce into the denominator? No. So just our NPVs. A cannot be 0. B cannot be 0. All right, second example. Starting to get a little bit trickier. So with this one, again, we need to say, what is my common denominator? I've got 8, I've got 6. That's going to be 24 between the two of them. Then x and x squared. The LCD is going to be x squared for that one. So LCD here that we're using is 24x squared. So I need the first one to be 24x squared and the second one. Well, what did I have to multiply the first one by? We multiplied by 6x. And what did we multiply the second one by? We multiplied it by, not 6x, sorry, 3x. And the next one by 4. And then we need to remember that there are always brackets around every numerator and denominator so that we are going to be distributing it. I'll rewrite this. 3x over 3x. And distribute that in. So now we have, I'll just write it as another step here for you so you can see what's happening. Let's distribute that in. If you want to, you can do it all in one step there, right to the next line, and bypass this one entirely, and that's fine. So then we get 3x squared plus 15x plus 4x minus 28 over 24x squared. Combine any like terms in the numerator. 3x squared plus 19x minus 28 over 24x squared. You got to look, can we keep going? Can we still factor? Is there any GCF in the numerator? No. Is the numerator factorable? Well, I gave you that quick little trick to be able to figure out if something's factorable. And that was b squared minus 4ac, the discriminant, has to be a perfect square in order to be factorable. So let's just run that through and check it out. So 19 squared minus 4 times 3 times negative 28 is going to give us 361 plus 336, which is 697. And that's not a perfect square. If you punch it into your calculator, it will not give you a nice whole number. So not a perfect square. So therefore, that's done. Comma, don't forget about your NPVs. This is your NPV, again, x cannot equal 0. And do the same thing for the next one. Might be a good idea to pause now here, see if you can do it yourself first before you continue. LCD for the denominators. We've got 3 and 5, so that's going to be 15. A c and a c squared, c squared. A d and a d, so just a d. In order to get to 15c squared d, we need to multiply the first one by 5c. And we need to multiply the second one by 3. So 5c bracket 3c minus 2. Again, you can skip this step if you do this one properly, because when you're subtracting, you have to be careful. There's a negative 3 that we're going to distribute in. Do not miss that. That is something that lots of people mess up on. So when we distribute that in, we get 15c squared minus 10c minus 3c minus 24. That's the one that people miss. 15 15c squared d. I'll highlight that one for you. Combine your like terms in the numerator, and then figure out if it is factorable any further. Most of them are not factorable again in the numerator, but the odd time they are going to be. Let's quickly check if our discriminant is a perfect square. So we've got negative 13 squared minus 4 times 15 times negative 24, 169 plus 1440, which gives us 1609. Punching that into your calculator, you can see it's not a perfect square. So therefore, can't go any further. We stop there with our NPV. Okay, so answering that next question, how do we know that the expressions cannot be simplified further? And we just talked about that. So put that into your own words of what you did. How did you know that it couldn't go any further? And last question now. Now we have 3 terms that we have to deal with. All right, here we go. We need the LCD for all 3 parts. We've got a 2, we've got a 4a squared, we got a 3a. So between the 2, the 4, and the 3, that's going to be 12, whichever method you do to get there. Then from the a's, we've got a squared, which we're going to have to do. And then what do we have to multiply each of them by? Well, the first one needs to get multiplied by 6a squared to get to 12a squared. So 6a squared multiplied by 5 over the 12a squared. So we multiplied that first one by 6a squared over 6a squared. Second one. Okay, and so for the second one here, we need to multiply it to get to the 4a squared to 12a squared by 3 over 3. So we now have minus 3 times 3 over 12a squared. Third part. We've got 3a. We need to multiply it by 4a over 4a plus 4a times 2 over 12a squared. And now we've got common denominators all the way along, so we can multiply and bring them together. So we've got 30a squared minus 9 plus 8a over 12a squared. Well, let's reorder that. 30a squared plus 8a minus 9. Please make sure that you're not forgetting about the negatives over the 12a squared. Again, we could look at, can we factor the numerator, use that strategy with the discriminant, and no, we can't factor it any further, so it stays as such, comma, we've got a, so a cannot equal 0. Don't forget about the NPV. Last one. Again, I always recommend you try it before you hear me talk about it. We've got 8z squared, 3z, and a 6. So our lowest common denominator between 8, 3, and 6 is going to be 24. And we've got a z squared and a z, so it's z squared. First one, what is 8 z squared missing? To get the 24 z squared, we're missing a 3, so we're going to multiply that one by 3 over 3. 3 bracket 2z plus 1 over 8z squared plus 3z. What is that one missing? It's missing an 8z. We're going to multiply by 8z over 8z. So now 8z bracket 4z minus 4 over 8. Oops, that should have been over 12z, or sorry, 24z squared. Minus. For this one, we've got a 6, so we need to multiply it by 4z squared. I'll just write it on the end. And I'm going to put it in front so that we don't forget to bring the negative in. If you expand right from here and bring it in, that's all good. You can do that. But please make sure when you are expanding that you're actually bringing in a negative 4z squared when you distribute it. Or distribute it in 1 and then bring in the negative after. So then we've got 4z squared bracket 8 minus z over 24z squared. Bring them all together. We've got 6z plus 3 plus 32z squared minus 32z minus 32z squared plus 4z cubed. And those two signs you got to really watch out for, because we're distributing in the negative with the negative 4z squared. Over 24z squared. Combine all of your like terms, and we get left with 4z cubed minus 26z plus 3 over 24z squared. We don't even need to look at factoring this one as a quadratic because we have cubic. So that's a 3, so there is no factoring yet that you have learned how to factor cubics. So we would stop there. We just look, is there a GCF that can come out? And there's no GCF, so we don't have to worry about going any further. And we've got z in the denominator, so z cannot equal 0. There's our final answer.